next we have a panel discussion on protecting users from MEV, strategies and solutions. And I'd like to welcome Robert from Allnodes, who's going to moderate the panel and to introduce the panelists. Yeah.
Oh, come up, guys. Just come and grab your seats. Yeah.
We're only 15 minutes late. So.
Wherever.
Yeah, just squish in there. Yeah, move it closer, why don't you?
Let's start by thanking the people for staying here after we didn't really started on time. So thank you all for staying here.
Thank you, everyone. So MEV, right? Let's jump right into it. It could be a topic that takes all day. Let's try to condense it into 30 minutes. Let's try to make it interesting. So starting from right to left, let's introduce ourselves and also tell us how you work with MEV.
Hi everyone, my name is Sue. I'm ecosystem development at Blocknative. We started our project about 4 years ago. We provide real-time data streaming into the mempool, as well as the dark forest. So we want to illuminate the dark forest, providing an equitable playing field for everybody. We also did a little bit more tooling around gas fees. So as you know before, you might have a congested time in the mempool. So we did that real-time gas fee. And now post-merge, we also operate the open source relay, and as well as we're block builder on Ethereum. So that's how we got into MEV.
Cool. Elias.
Can everybody hear me? Cool. I'm Elias. I'm co-founder and CEO at Rated. We're on a mission, really, to build the most complete picture of Ethereum infrastructure, including validators, how validators perform, and sort of risks they carry, but also like this increasingly complex transaction value chain that involves builders, that involves relays, and so on. So you can find us under rated.network. We have a dashboard that we basically expose all of this in what we think is a pretty interesting and easy to consume way. And we have like a bunch of other things that we're working on that are out of scope for this conversation.
Hi everyone, Uri, CEO and co-founder of bloXroute. We're called bloXroute because we route blocks and transactions. So we have a blockchain distribution network. We propagate transactions and blocks roughly at the speed of light, under 140 milliseconds globally. We got into MEV because prior to Flashbot and before all of that, when DeFi started in really started in summer of 2020, then a lot of people wanted to see the latest block really fast and wanted their transactions sent to the mining pools really fast to make the best trades and see what other trades are happening, so they could also trade on CeFi, etc. And as Flashbot came out, private transaction became even more of a thing. Now post-merge, we're a major block builder, we're a relay. We also provide MEV solutions for BSC, for Polygon, also have our solutions for Solana. So basically everything that comes down to DeFi execution, which MEV is a part of.
Hello, I'm Luis. I'm a product manager at Shadow Network. Shadow Network is a MEV protection mechanism using threshold encryption, so essentially providing an encrypted/shielded mempool. We are implementing, so essentially we're primarily targeting it to be a plug-in to other protocols like an L2 or even an L1. The most advanced we are with implementing it is with the Gnosis chain. So there we are essentially working on a version of what we would call a shutterized beacon chain. So that will be probably the first shutterized infrastructure in this way. And then we also have the same sort of threshold encryption commit and reveal scheme running to shield votes and there as a plugin to Snapshot. So if you have a Snapshot DAO, you can switch on this shielded voting using the same threshold encryption that we would use for MEV protection.
Cool, thank you. So I'd like to throw this to the audience, wake you guys up a little bit. Hello, wake up everyone, it's MEV. By a show of hands, who knows what MEV is? This is a pretty crypto audience. Okay, so I'd say like, I don't know, what would you guys call that? 70%? 89, wow, very precise. So for the 10% left, Uri, do you want to tell us like really quickly what MEV is, but more importantly, why is it good? Why did it come to be?
Sure. So MEV or MEV, maximal extractable value, is basically the money that validators could capture from being the one building the block. That means mostly, imagine price on DeFi and price on CeFi is the same. Now price of ETH on Binance goes up and there's an arbitrage opportunity. Validators are the one in the position to capture and extract that value. If somebody is making a giant trade, okay, somebody buys lots of ETH and is going to move the needle and increase the price of ETH, then you could imagine it will be worthwhile for the validator to buy and front-run that transaction, buy before the price goes up, and then once price goes up, sell these ETH. So this is called sandwiching. Front-run the transaction and back-run it. These are the main types of MEV out there. Also liquidation. Okay, some collateral gets out, some position is under collateralized, they can be the one jumping to extract value. So there is a lot of money in being the ones ordering, including, excluding transaction in the block. So this is what MEV is in general. More specifically, and within the Ethereum ecosystem, we now have an MEV ecosystem where we allow people to optimize and maximize and do all sorts of stuff regarding MEV. And the question I really want to answer is, why the hell did we build it? Is that a good thing that we build it, if this extracts value from users? I have some strong opinions around why it's bad and why it's good, etc. There is one thing which is important, and the reason this entire thing exists and as an infrastructure right now. If there's money there, then validators would extract it. Okay? If we don't do anything about it, then large validators with a lot of stake could hire good engineers to build good infrastructure, and when they build blocks, they extract a lot of value. While if I run a solo validator at home, I don't have these resources, and my block won't be nearly as valuable. So their APY would be 7-8%, my APY would be 4%, and in that case, you could imagine that most people, oh, what should I do with my stake? Should I solo stake, or should I stake with Coinbase or Lido or Rocket Pool or whoever? And everybody would stake with the largest, and the largest one will be the best, and kind of like it's a very strong centralization force. And so the reason MEV infrastructure exists is to say, well, if instead of each validator building it by themselves, we allow validators to offer it to third parties. Anybody could offer me a block. This guy offers 1 ETH, this guy is 1.1, this point. Okay, this guy gives me 1.2, I'll sign his block. The different block builders, kind of like, they keep a percentage to themselves, but they make an auction out of it, then that allows all validators to get the same APY. We get rid out of this centralization force. I have a lot to say about the bad stuff about it and why it's not good.
We'll get to that. We'll get to that.
I know, but that is the good thing. The reason to have an MEV infrastructure is to say, listen, we really don't want that, so we need a solution not for everybody want to stake with the largest validator.
Thank you. So let's get right to what Uri was talking about, which is the bad. We could position this, I think, from a user experience. Starting with you, Sue, what are the challenges facing the user interaction with MEV? What are the bad experiences, and what are people like yourselves or like your company trying to solve for?
Yeah, I think that's a really interesting question, and it has come a long way as well. So in the really original version of MEV pretty much years ago, and what happened really bad is that it's just like really congested network, high gas fee, because there were searchers just trying to spam the ecosystem. And then you have the Flashbox version of the MEV, which are then trying to have a private channel for the searchers. So they're already kind of mitigating partially the negative side of the MEV. And I think as of now, it come a long way. It's a pretty competitive landscape as well. And the question is really, how much are users aware of it? And I would say maybe we still lack so many general public awareness on the topic. And it's also how much is implemented at the dApp level. So does your DeFi protocol provide some MEV protection to you? Does the wallet enable some kind of that? And I believe that's going to be a topic for this year, for the next 7-8 months. And it's already starting the communities about MEV sharing. So it's about how to empower users, how to share some of that math rewards back to the users, and how can we implement that in a really simple UI, UX at the dApp level?
Thank you. We'll continue on this subject a bit, but Elias, you sort of monitor this across a spectrum of builders, searchers, MEV in general. How are you looking at it at Rated in terms of, like, I guess just data analysis? What are you seeing? What are you looking at?
We're still largely in like an exploratory phase because the ecosystem is also developing like super fast, right? So we're in a place where we're trying to understand basically what sort of the implicit contracts are between this new emergent value chain, right? Like a builder promises something to a searcher and expects something in return. Then the relay promises something to a builder and expects something in return. And then the relay promises something to the validator and expects something in return, and vice versa. So this is all just like happening pretty much live and happening super fast, and like new versions are coming out, and like, you know, there were relays and now there's optimistic relays, and then tomorrow maybe it's going to be relayers not going to even exist, and so on. That it is even hard to actually grok what these implicit relationships are, but where the disconnect, and I'd love to hear what Uri thinks about all this, the disconnect is in that there is so much value at stake, no pun intended, and these agency relationships are actually not very clear, right? And then the whole sort of spiel behind the thing that we're doing and we're moving towards is this idea of a reputation for machines, right? And the objective functions that these machines, the builders, the searchers, the relays, and the validators themselves sort of carry through as sort of agents of their operators, the people that tune them, can actually also, we think, can be used in interesting ways to express preferences, right? And minimize or maximize different types of objective functions, including maximizing or minimizing MEV.
Yeah, you bring up a really interesting point. There's like the Ethereum assembly line, right? And so as we move down this road, Uri, how do you think the roles between all these entities in the assembly line will maybe evolve? What are their roles even?
Yeah, so I was thinking, let's start by, for those who are not spending all their day, all the time inside the MEV space, say like, oh, what parties do we have here and what are they doing? So we have users, they're making transactions, right? We have this role, we have searchers. Searchers are out there listening to transaction in the mempool, maybe or maybe not have access to some private order flow, just people sending transactions just to them, and they're looking to extract MEV. It could be people just trying to extract that value. It could be a service that says, oh, I'll protect my users. I'll take that, I'll extract the value and give it to them so there's no money left on the table. These are the searchers. They create what's called bundles of transactions. Then you have block builders. Block builders listen, might be searchers themselves, might not, receive these bundles from other searchers and try to make the most valuable block. They also might have private order flow, so people sending transactions just to them and trusting them not to front run them or to back run them and give them their money back, and these kind of and similar services. So we have searchers giving their bundles to block builders aggregating, trying to make the most valuable block. Now you could imagine there are some like relationship between bundles. One searcher does one bundle, the other does a different one, and maybe combined they make more value. Okay, so this isn't visible to anybody, to each individual searcher, but the block builder could try to make the most valuable block from that. Block builders are fairly centralized right now. We have like one of them controls like 30% and the other like 20 and then another 20. And so it's kind of like we're talking about very few actors with this access. And then in theory, the block builder would try to make the most valuable block. Let's say it captures 1.5 ETH, and then one of them said, well, I'll give 1.4 to the validator, the proposer of the next block, and then there'll be an auction. However, if the block builder just give it to the validator, you could imagine the validator say, oh, thank you for building this. I would throw your cut. I'll take the whole 1.5. I will change that block and I'll extract all the value. So the validator could screw over the block builder. On the other hand, it's also the other way around. The block builder can just say, oh, sign this and I will pay you, because maybe he doesn't. He doesn't give him 1.4. He doesn't give him anything. So they have a problem of trust, who can screw over who. And so we have another entity between them called the relay. The relay is a trusted party. Okay, this is Ethereum right now. Most people are unaware how it works. The block builder gives the relay. The block relay looks and says, oh, it is actually paying 1.4. It goes to the validator and says, like, sign this. I promise you it's 1.4 ETH. It would actually pay you that amount. The validator signs it, and the relay sends it to everybody else. So this is these are the different pieces out there. You have the searchers, you have the block builders, the relay, and the proposer. This is very different from vanilla Ethereum peer-to-peer network in a lot of ways.
I got a question.
Shoot.
I think it will add interesting context to everybody if you also talk a little bit about what modulates block value, all other things being equal. Sort of outside of this value chain, let's say that there's a constant flow of transactions and that's kind of a given. What are the parameters that will actually define what the competitive landscape looks like, right? Like how does block value get
So
modulated?
half of MEV is CeFi DeFi arbitrage. Okay, think about it. This isn't live stream or anything, so there's shitload of liquidity sitting on Uniswap, and it quotes price, and these prices are 12-second stale, okay? There is a price right now. You could imagine that within 12 seconds, this price is wrong. So all the CeFi DeFi arbitrageurs, the high-frequency trading in crypto, you all know their names, they are all trying to capture that value. So if price on Coinbase and Binance go up, they're kind of like, okay, they'll send their transaction, they'll try to buy low on DeFi and then sell high on CeFi, or vice versa. And so CeFi DeFi arbitrage is by far the largest piece out there. The second piece is front-running, or sandwiching, which I mentioned earlier. An interesting point on this is that people think, well, if you make a transaction, if you just don't put too much slippage, and you should be good, right? You won't get sandwiched. You created it just fine. Shout out to P. McEwen, who built like zero MEV thing. You can go there, put your address, and see how much money you lost to sandwichers. I learned that, and I'm not a big trader at all. I'm busy. I lost something like $4,000 to sandwichers, and I didn't even know it. And I know probably more than 99.9% of the people about MEV. So when you make a transaction, you say, well, what's the current price on Uniswap? I'll buy at that price. And you put zero slippage. Why would you allow for slippage? If the real price, centralized exchange price, went during this time down, then you overpaid, right? You will be sandwiched. Somebody will come there and say like, oh, this guy's willing to pay for so much. So, okay, let's let him buy at this price, and then afterwards kind of like sell and correct the price. So when the CeFi DeFi arbitrager come and correct the price, you'll be sandwiched along the way, so they extract value from you. If the price went in the other direction, so price went up, you're underpaying, so your transaction would fail, right? So you send a transaction, you want to buy it at 2,000 ETH. What do you know? Now it's 2,100. Okay, you're not getting it. So you add some slippage because you don't want your transaction to fail. At which point, you always get sandwiched. You either overpay this way or overpay the other way. The only way for you not to be sandwiched is if you guess correctly what the price would be in 6 seconds. So you set the slippage just right or close enough so you identify what the price would be. And if you can do that, well, you shouldn't be here. You should be running jump or something. Does that answer the question, Elias?
Thank you, both. Sort of. I was also wondering if you could touch on so builders basically compete with one another, and searchers compete with, is my understanding, right? And then you have this like really sort of key, pivotal, dumb object in the middle between builders and validators, which is the relay. Now, what are sort of the resources that searchers and builders use as an input to compete with one another? Is it like CPU? Is it like access to order flow? Is it like a combinatorial problem? Could you talk to that a little bit?
So first of all, order flow and access to private order flow is a really big thing. But really much worth mentioning, Searchers, these guys who look for opportunities, don't really want to trust the builders. The builders are also searchers, almost always. And so generally, they wouldn't want to give them their bundles and trust them. But you could imagine that if there's a block builder, and he's building 30% of the blocks, if you don't send him your bundles, you're losing out on 30% of the opportunities. So searchers are kind of like forced and don't really have an option and have to trust the block builders and send them their bundles. They don't really, they can't do much about it. Usually it is the block builders, or a lot of the time it is the block that has additional order flow. They have to actually spend quite a lot of effort in simulation and computation. So as in these 12 seconds between one block and the other, it is really the last 200 milliseconds that matter the most. We reach the money time. OK, what's the price difference between CFI and D? This is where everything starts. OK, new updates, and this one offers this amount, and that one offers that amount, and it goes into risk and latency to centralized exchanges and all these other things. And then they create that. And now block builders give it to the relays. Relays are, like, as somebody who runs a relay, Blocknative also runs a relay, Flashbot runs a relay, Ultrasound and Agnostic are the largest one. We're nice people, so you all basically just trust us to relay them and not to screw everybody over, and we have no incentive. We actually have a strong incentive to screw everybody over, and basically you all just trust us not to do it.
Yeah, Uri, what's preventing, so I work for a node operator, we have 2 relayers here. What's preventing us from, or what's not preventing us from collusion? So, why don't we make a deal in the back room?
So just yesterday, somebody said, why are you running a relay? And you should run a relay because it makes you money. It's like, this pays no money. So like, oh, so you're probably just an extension of a block builder, right? And like, no, I can't be an extension because I'm being trusted by the node and by the... So like, why are you running it? And I said, that's a great question, but not really good answer for it. And so the relay sits in the middle. You could imagine that the relay could do whatever it wants. I get a block, I can unbundle it, front run, back run, extract, do whatever I want to the searchers, promise, I will pay you $100 million if you sign this block. You trust me, so you signed it. I give you nothing. I take all the money. I walk away. And so, yes, I'll do that.
I know where you live.
You move, and you do it more than anything. You do it anonymously.
There is an incentive, right? Which is like in classic like game theory. You have like one-shot games and you have multiple round games, and then the incentive structure in one-shot games is completely different than the multiple round game, right? So if it were a one-shot game, so like we all like gather around, we place our bids, there's only one block in the history of the universe and that's it, then surely that's the dominant strategy, right? Like you grief everybody and then you go home and you retire in some like exotic island. In a multiple rounds game, where you also like have an organization that you're building and you're trying to like promote the interests of the ecosystem and grow it, then because you have a long-term view, then argument to be made that there's actually a pretty strong incentive to act virtuously.
So yes and no. In this long, yes and no, and we would just move on. We're, as a relay, or the current MEV infrastructure is trying to say, well, we're trying to have as little value leak in the middle to the relay and the builder and the searcher. So if you have an auction, basically everybody try to auction up one another, and whoever pays the most gets it. So it's kind of like it leaves the least value possible, and all the value go to the validators, and from there to their stakers. So CFI DeFi arbitragers make money, so that's their game. Like, they make actually good money. Searchers make some money, block builders make some money. Relays don't do nothing. Like, we're not being, like, this is a free service that we're giving that literally gives us nothing in return.
Just to add something here, and I think it's also most often also ignored how much value that relay carries. First of all the blocks produced by the relay carry small transactions. That means that we're using the block space more efficiently. You will have more fees burned as well. And second of all, it can also be negative, right? Because sometimes if there happens there will be something missed, you know, you will be coming, validator coming to us, we want to be payment back. So until a lot of real critical infrastructure, got to be 100% uptime, 100% connectivity, and you need high CPU to do full simulation. So I think there are a lot of value just being ignored, and well, with no economic incentive.
Yeah.
Yeah, so to sum up, relayers don't make any money, and we're trusting people.
I think the not making money is the less important part. The idea is that we're talking about like MEV solutions out there. MEV blocker, like we created like background me like 2 years ago. I think Blocknative, you guys have, I think one, I thought you have. Okay, so you have a lot of like MEVs, think cow swap, all these stuff. We say, okay, listen, we're creating this and we're protecting the users, and that is correct. But eventually that block with these transactions go to the relay, and the relay could say, oh, I'm just going to take this, unbundle it, do whatever I want, and then promise whatever I want to the validator, and that's it. So it's not really protection, it's trust. And you can trust and it works, until it might not. So I'm very bullish and almost hawkish on DeFi being useful, being competitive alternative to CeFi. And there's something very, very nice about vanilla Ethereum peer-to-peer propagation and everything around, where it's like, you really send it out there and don't need to trust anybody or third party, etc. And there are negative stuff, which I'm sure Luis can kind of like a bit talk to on the solving side. It's kind of like, this is the structure that you're all currently using. If you're using like MEV protection to protect your trades, you're really just like trusting them or trusting eventually us, the relays, not to screw you over. And we're nice people. We don't intend to screw you over, but it's not really a robust incentive-aligned mechanism, which is what blockchain is all about, right? You don't like validators. You trust that their incentives is to produce blocks that include your transactions. Except Easy over there, he likes validators.
Yeah, I mean, that brings up the high-level point, right? There's no de-incentivization built into how this all operates. So let's pivot the conversation. There's a lot of solutions on the table. There's a lot of roles on the table. It changes every week almost. Luis, to bring you in the conversation, could you talk a bit about Shutter, how you guys are sort of looking at solving for this?
Yeah, you're saying like, yeah, it's very correct. I think there's a bunch of solutions, right, and not a single solution is going to solve everything. In a way, PBS is one sort of broad solution that unbundles everything, helps with sort of the tendency towards centralization. I would say all kinds of sort of auction mechanisms are also part of the solution, I would say. But maybe to sort of focus on the solution, or the one sort of piece of the solution we're working on, sort of the mempool encryption. Maybe to motivate this a little bit. So, right. So Uri was talking about sort of these trust assumptions for various centralized intermediaries along the MEV supply chain, and essentially the encryption is one sort of idea and one tool we would have to reduce the trust assumptions. Right. So if you think about it, on the larger time scale, we have decentralization, right, as a tool to combat the need for trust. On these very small time scale, sort of the 5 to 10 second time scale, then decentralization doesn't really work there because there's only one entity in this small time scale. So the nice thing about encryption is it allows us to do something, to achieve something similar by saying the one who, for example, the block producer, has to sign on top of, or has to sign the inclusion and the ordering of transactions that are still encrypted, so they don't see what's in the transactions. So ideally, then they also can't censor or front run. Yeah, but very simply spoken, how it works is you encrypt transactions at the user level. Ideally, they pass them to the block producer. The block producer signs on these batches and signs and commits to an order and inclusion of transactions while not seeing them, while they're still encrypted, and only then afterwards is it being decrypted and executed. And I think the important part is also this kind of needs to be in protocol, right? Because as you said, if you build it outside of the protocol, you can then sneak in transactions afterwards again, or you can unbundle the bundles. So it kind of needs to be in protocol. This is why it takes longer, a little bit of a longer time. Yeah, maybe one note on sort of there's multiple, I would say, encryption methods, right? You could use something like Intel SGX, which is probably a practical solution right now. But yeah, you're kind of trusting sort of the hardware side of it. Intel Shutter works using threshold encryption, where you're more sort of relying on the cryptography and the decentralization of the keeper set that are sort of generating these key and this distributed key generation mechanism. Yeah.
Can I push against that for a second?
Sure.
Get I?
What?
Can I push against that?
Yeah, go.
I think what bothered me the most about the MEV landscape is that we don't have good enough solutions. So you could say, okay, let's encrypt all the transactions, so we send them this way. It seems like it solves it. By definition, though, if we encrypt it and then wait for a majority of the validators or whatever to kind of like do a threshold encryption, so until we see what's inside it, we slow everything down. That's the trade-off here. We can okay, they don't see it. You could do statistical spamming. It's kind of like, well, I'll send a transaction. Maybe it catches MEV. And if there is MEV to be caught, it will catch it. So you spam the network with transactions that might try to blindly try and catch MEV. And the second that it slows everything down, and I probably feel more strongly about it than almost anybody else in the ecosystem, I want DeFi to compete with CeFi. I don't want to be like a sidecar where the real trading happens on CeFi. And arbitrage is being caught on DeFi. That sucks. And so if we slow things down, we make things worse. The faster, if I'm a big hedge fund, trade entity, whatever, I send a trade, I want to get the current correct price, I want it to happen with the current price, and I want to know whether it executed or not. I can't, let me wait 12, 15 seconds, and then maybe I'll get it at the price it will be. Yeah. So that's the strong trade-off I see in encryption, which makes it not, it's not the silver bullet that solves everything.
I agree, definitely not the silver bullet, but maybe to two sort of aspects of this. One, I would say, is I think in the previous panel they talked about the difference between inclusion latency and execution latency. So I would say sometimes, in an encrypted system, you can still have instant inclusion latency. What you don't have is the instant execution latency, sort of. Yeah. So it could matter to the user more to have the instant inclusion latency. That's maybe the one thing I would say, and we can still provide that in the encrypted system. And the second aspect I would say is more around this topic of the trade-off between latency and geographical decentralization. So I think Phil Diane had this great blog post where he said, if we want to have geographical decentralization, we sort of can't have super fast latency. So I feel like one answer could be that maybe we have to accept sort of a certain minimum kind of tick size, and that's something that they're also trying in the real world. These MTFs or these sort of alternative trading facilities that have this minimum sort of latency, like IEX, I think is one of them. So I think that would be the second aspect to it.
Just to add on here, I think there are general kind of two camps at MEV. So you have the one camp that's saying, how do we just eliminate this? We don't want this at all. And I'm on the second camp, which is kind of like, MEV is kind of like a part of the nature of any economic system. So if there was like a transfer of value to be there would be somehow unavoidable. Some people trying to extract them. And I guess I'm always looking at the perspective, how can we leverage that? So right now, if you guys follow a bit more the Ethereum protocol, so people are talking about MEV burning, MEV smoothing, and as I mentioned before, how do we solve at the depth level with the wallet? So that's more about MEV sharing. So I think this is how I generally look at more MEV topic. Now just I don't want this anything at all. There's probably what we mentioned, there's probably good side and bad side. And now with the MEV boost relay, I mean, the stakers are also getting more higher yield just because from the MEV boost. So,
yeah, interesting to note for everybody. Basically, lower latency means higher block value, right? Or really, because we talked a lot about latency. What's the real role of latency in this whole new value chain?
So two things. First of all, there was this idea where, if we do an auction, then latency doesn't matter and everybody are kind of on equal ground. And then, as I said earlier, it turns out that it really is about the last 200 milliseconds and here about getting from. So it's still that. And us as relays, basically, we need to, let's say somebody just created a more valuable block. I need to receive it and simulate it and be ready for the validator to come and ask for it, and whoever is the fastest at it would accept. So it's still there. We didn't really get out of it. for me personally, the thing I feel very strongly about is if DeFi is slow and LPs continue to bleed money because they only make like they don't trade up and down, kind of like as price fluctuates. They only make one bad trade every 12 seconds and bleed out money. Then yes, we extract that value and we get higher APY to stakers and maybe MEV burn and it increases the value of ETH. This does nothing to help the LPs bleeding money. Okay, this is like great, it's great for many other people. It's not better for the LPs. If LPs are bleeding money, they're not going to LP. Okay, they're not going to put liquidity there. DeFi is not going to grow and compete with CeFi. One interesting data point is that on CeFi, BTC trading volume is twice as much as Ethereum trading volume. Regardless of what you think of whether BTC is good or bad, like it doesn't matter. It is being used on CeFi. On DeFi, it's 0.5% of the CeFi volume, okay? Why? Because if you hold BTC, do you make more money if you trade it on CeFi? Or if you use WBTC and LP it? If you'll do that, you'll bleed money. So us ETH heads and DeFi maxis, and what's like, okay, we'll put our money there, like it's a good thing, we're supporting the ecosystem or whatnot, etc. It's not a very smart economic decision. You could dynamically manage your, like if you're a giant hedge fund and you're kind of like, okay, you keep changing your position and how you LP, then it's actually a good deal, but it only works if you have really a lot of money, so the gas fees are kind of like, yeah, who cares about that? And so, is DeFi useful? BTC trading volume indicates that it isn't. And so going back to your question, I want DeFi to be useful. DeFi has a lot going for it, okay? No KYC, transparency. It's not going to pull an FTX on you and disappear with it really has good stuff working for it. But on CeFi, when I make a trade, I get the correct price. Whatever the price, again, I'm not trying to be faster than jump. I want the current price. I just want to get whatever is the fair price right now. That's what I'll get on CeFi. And on DeFi, I will get the worst possible execution. Okay, that's what I'm going to get. I will be front run, I will be sandwiched. The worst thing that I could, that's what I'm getting. And that's not good enough. So when I'm thinking latency, I want people to trade, get the current correct price, etc. That's what drives me, at least.
So we're running out of time, guys. Sorry about that. We're already over. So as you guys could tell, MEV is like such a vast topic. It could really take up the whole day. We didn't get to touch on MEV burn, MEV share, all the things going on. So I'll just throw this, and just to note, a lot of people did ask questions. I hope most of them were answered. But since we're running out of time, just for the sake of that, I'll just throw this to all the participants. Sort of a two-part question. What do you see over the next 6 months? And more importantly, maybe, what excites you over the next 6 months in terms of the MEV landscape?
Yeah, I think this is probably going to be an exciting year on order flow auctions. So what I mentioned, the volume boost, which we call it the MEV share at Blocknative. And I think there's already a lot of exploration. CoSwap is kind of batch auction space, but I think we will probably see a little bit more implementation at the wallet level, which is the quote-unquote sleeping giants at the MEV space. And I think that's going to empower a lot of users then.
I'm excited to see how this in-protocol PBS roadmap pans out to look like, right? Because like one of the most fun and also maybe not fun things about this industry is that the most permanent things sometimes are what are touted as the most temporary. So the relay is like an agent that is about or is slated to be abstracted away from the whole pipeline, but sometimes plans change, right? So there's already kind of fast developments and changes. So USM, I think, launched the optimistic relay. The optimistic relay is this mechanism that basically reduces the latency that the relay builder validator relationships are beholden to, increases value, introduces some new risks. This is like step one. And my understanding is that within the next 6 months, we're going to see like step two and potentially like the next evolution of that. So I guess that's what I'm mostly excited about.
Cool.
I will just chill for a second. So we're doing like an MEV Talk side event today at 6:30. Like, why is that a bad thing?
I'm excited about that.
I'm excited. I'm excited about that. Come, we're going to continue this conversation there. I am very excited about ways for DeFi to compete with CeFi. That's literally the thing that drives me, and that's the reason why I'm doing anything that I'm doing in this space. That's the thing, okay? Since FTX imploded, we need to build better DeFi, so users choose DeFi over CeFi. Otherwise, we're going to have FTX and Celsius and Voyager. That's the thing that drives me.
I'm also excited about the evening event. Great.
It's at 5:30.
And then encrypted mempools, obviously, and also I would say and this connects to the previous panel. Sort of some of these different opinions on what the perfect marketplace, what the perfect sequencing engine looks like. The nice thing about these rollups is you can sort of experiment, and you can have one rollup with these and these properties, and the other one with the other properties. So this is what excites me, is that there will be many rollups, and they will have the MEV sort of strategy as a differentiation factor. So, yeah.
All right, well, I guess that's time. Thank you, all the participants. Thank you, everyone, for listening.